Good morning, everyone. Welcome to my deep dive, Spring Boot in the Cloud, Advanced Optimization. So you probably know running Java applications in the cloud is sometimes not so easy. And actually, like in the next 3 hours, we're going to see what actually you can do to optimize your Spring Boot application from many different perspectives. We'll do some look at some topics, and then actually we will have also a look how to use that actually in practice, and how you can actually improve your application in a container setup, actually. Yes. So my name is Patrick, and I'm your host for today for the next 3 hours. And if you want to follow along, actually like the presentation, and if you want to have a look at the code examples, I put the QR code already here. So you can have a look at my GitHub repository throughout the session, but also afterwards. I will have it also at the end. But I think it's just nice if you do some note-taking or so, you can directly make them in the slides, than just on paper. Great. So let's just wait a few more seconds until everyone has taken the link. And then we can start. You will actually realize that what you're going to see is working with my current setup. So I did some benchmarks to show you what an improvement could actually result in, and how much better or how much worse your application will get with doing some optimizations. So be aware, just like I did it on my own machine. It's a machine in a cloud setting, but probably your application might be different, and you still have to benchmark your application yourself, right? So be aware of that, like a responsible adult, thinking first, measuring, and then actually do the changes and do this in a loop to improve. So that's why I'm saying the numbers are just estimates or assumptions, because some numbers might look strange. They even look to me strange. I would tell you in some cases that I would expect optimizations going in that direction, and they really should, but then my numbers show something different. Be aware of that, because when I did the benchmarks, I'm going to show you. The thing is, I can't run that 1,000 times per optimization, because it will take forever, or I would have to have many servers to do the same, and I just do not have the time. I mean, I do not have the time means basically my current benchmark suite runs more than a day, and if something goes wrong, you have to fix something and then continue doing the things. So actually there is about 2 days involved actually in taking the numbers. So be aware of that. And it's also not marketing numbers, so I didn't change anything. It's just the numbers I got from my measures. So yeah, be aware of that. Great. So who am I? I'm Patrick. I'm from Switzerland. I'm working as a consultant, as a trainer, but also working as a teacher at the University of Applied Sciences in Zurich. I'm very much involved in the Java ecosystem in Switzerland. And I would say in the last 2.5 years, I dedicated quite a bit of time in making my Spring Boot applications faster. And also have some examples where I do that in real production applications. So that's basically my background. And I'm in the Spring ecosystem since around early 2008. I started using Spring, so it's quite a while. And over the time, of course, I get quite a lot of knowledge and experience in the field. And of course, also with Spring Boot and all these other fancy things from the Spring ecosystem. So be aware of what I'm going to show you today is way different what Josh Long showed you yesterday in the deep dive. So I'm not going to do a lot of coding, or maybe I don't even do coding, but it's more the optimization part, which is important here. So I always say I'm going to show you what Josh Long is not showing to you, So how to make your application really faster. But of course, Josh does a great job, and even I learned something yesterday from him in his deep dive. Great. So what's actually the challenge? Why does the whole thing matter? When you're going to the cloud, you will actually realize that you have no idea how you should size your application, how it will behave in production, and so on. And to find out, you have to measure. And probably you also have been watching yesterday evening a talk about sustainability by Co. And that also matters more and more. Using CPU cycles more efficiently, having less CO2 produced by the data centers, and so on, because we want to stay a little bit longer on this planet and not just like blow it up tomorrow or like the other day, right? So we can do something about that, and that's why I think it's also important. And it's easy actually to sell, because to your manager you can tell it's cheaper. The cloud resources get cheaper if I do these optimizations, right? So that's just the thing. That's why I think it matters and why you should actually change the thing. And of course, I like Java, and I also like Spring Boot, so that's why I'm here, and we will work through the whole thing together. Great. So let's dive into the topic, and let's think of optimization goals in general. So I brought with you a warm-up exercise, because I think it's early morning and you should get warm. So talk to your neighbor. And if you don't have one, get closer to someone you don't know and ask yourself in the next 3 minutes how you should optimize your application, or what you should optimize for, how you would measure it, and so on. So just like have a small chat to your neighbor and try to find out like what could be ideas to optimize for. And afterwards, I'll tell you mine. That's perfect. I just get the photo session right now while you're chatting, so that's perfect. Thanks. I hope you made some friends for the beers tonight. So if you're alone here at DevOps in Antwerp, maybe you got to know someone you will meet like throughout the conference. That's awesome. That's just the way I wanted to start. And I just brought some ideas with me, and I'm pretty sure you can fit the things you talked about in those categories. Of course, let's start with the application itself. You can actually like optimize your use case. Doing like less things, maybe do the right things the right way. It's always possible somehow to optimize your application. Another thing could be actually like to optimize your build time, because the faster you get something into production, the faster feedback you would have. And then on the other hand, if you think of network, if you can reduce the image size of your container, for example, then you have less traffic over the network, right? Think of startup time in your application, so that you can scale up faster. I have a customer, they run like with 2 instances throughout the day, but at 9 o'clock in the morning, they have a peak. They need to immediately start up another 6 instances. So the question there is like, how can I achieve that in a good way? How to like not start like 5 to 9 or even earlier, to be ready, right? To just like maybe use the horizontal autoscaler, but with a good threshold. With some threshold, you can actually save money, right? And so on. So startup time might matter as well. Then actually like the CPU usage in general. So how you can optimize it, how you can make your Java application better and more responsive. Maybe getting more throughput through your application. So having more requests per second. Thinking also of latency. So if your service is answering faster, you probably need less other instances, and so on. And of course, also like memory consumption is a thing. And especially if you think of some services which are designed that CPU and RAM is basically like tied to each other, so that if you need more RAM, you have to buy more CPU as well in certain cases. Maybe you're just like at the edge, and the idea would be to maybe reduce the memory just to save or not to pay so much CPU. Great. So the challenge is definitely like when you have a new application, we usually say it works on my machine. Developer hardware is probably like way more stronger than what you have in the cloud. So we sometimes or often do not know like what we need. And that means like RAM, storage. The question is maybe also like which stack we should use. For me, my favorite stack would be Java and Spring Boot, of course, because I have a lot of knowledge in there. But if you think of like switching to another stack, it takes you a while to switch to another programming language, to another platform. So maybe you want to use what's there already, and also with the team. And then also the question depends on like what kind of application you're building. So if it's more like serverless functions, single calls, or does it need to stay like alive and running like for a long time? Or if it's a batch job which runs overnight and so on. Great. So this was kind of the introduction I wanted to show you, or the motivation, what we are going to look at. And basically, like, these are the topics I'm going to cover. So we will have a look at the Spring PetClinic because I use it as a reference for comparison. Then we look at some JVM optimizations. We look at Spring Boot optimizations. We have a look at application optimizations, just like from one perspective. And then actually also we look at different runtimes. You could say Graal VM is part of that as well. And in the end, I give you some conclusions and like a summary. And we will really like dive into it, and we will see and understand how things are working behind the scenes. So it's the idea of these 3 hours that we really like can like see logs and interpret what it means and so on. And also like run from time to time some builds and compare things. Great. So you probably know the Spring PetClinic is kind of this application. And if you think of the Spring PetClinic, which is just like a CRUD application, which uses server-side rendering, this kind of thing is quite simple. It's not a big application. It's like, I would rather call it like a small application. But there, just like for reference, and sometimes I will do that, I'll just like switch to the links I have in my slides. Just open the tab here. There is a thing actually like which is called the PetClinic community. And I'll tell you that the thing here is quite interesting because it contains quite a lot of different implementations. Not just like the regular ones, but also, as you can see, there is a Spring PetClinic in Kotlin, there is one with Angular, React, Vaadin, you name it. Basically, for me, it's also like a starting point to see if you want to integrate some UI technology with your Spring Boot backend, or if you want to do something like microservices and so on. There are quite a few examples in there. And even if you want to have AI in this session, I think that's the only place where it pops up, right? You can see like PetClinic with LangChain4j. Good. So I'm actually talking about the real PetClinic. And the real PetClinic is the thing which is actually part of the Spring project. So it's an official Spring project, actually. It's not like a playground or so. It's really like an official project. And I'm super happy because I did some updates for the thing. And I even did a pull request, and I usually do that for these kind of sessions, that I have like the up-to-date PetClinic with like the latest dependencies and so on. And that just got merged yesterday, actually. So just in time for being here. So if you want to follow along and just like do some optimizations on your machine, you can just like clone the PetClinic from the GitHub repo and try some things out if you want to. Right, good. So let's jump back. I will tell you about a few limitations you usually or you might face if you do some things. And also I'll tell you like how I do the measuring before we dive into like the real things. So sometimes when you run your measurements, you have to pay attention depending on like what kind of environment you're running. And it was for quite a while that, for example, Docker and how the memory was calculated was done wrong in the WSL under Windows. So as you probably have seen, I'm using a Windows machine. So there, usually it did not work. And if I wanted to do it locally, I had to restrict my WSL to a certain amount of CPU and memory, as you can see at the bottom. Right, and you will see that actually like this kind of like parameters were ignored because I used Docker container stats to see like how much resources were used. So this was like one challenge I faced. So make sure before you measure anything, you measure the right thing and you're aware of that there might be some limitations. The measurement I'm doing on a Linux machine, and there it's working perfectly fine. Another thing which is quite nice is a thing I learned from my friends from the Quarkus team. So they actually made a nice blog post about the thing that, give me a second, I'm just jumping over there. Yes, oops. Oh. My touchpad behaves a little bit strange. They are like describing how you measure correctly the memory usage in a Docker container. So you could use actually like Docker stats, but it will tell you like the wrong thing. So it's way better actually like to use Docker top because that gives you the correct numbers. And you can actually have a look at the blog post itself because it's linked in my slides. They will also explain like how they do the measurement. So I try to measure the same things like the other people in the other ecosystem, right? So we can better compare things if we do it the same way. Okay, cool. So that's just what I wanted to show you. So use Docker top and not Docker stats to parse your data. Now, if we are doing the benchmarking, you will now see I do some steps. And actually, I use a load generator, which is quite nice, which is called OHA. And they also have a very nice GitHub repo. Hey, come on. So it was here. Because I wanted to show you the animation here. So this one actually, if you run it, you can visualize basically. Come on, yes. You can visualize basically like your load test, and you're seeing what's going on. But you can also do that with a parameter, and you can say export JSON, so you can parse that in your script in an easy way, right? So that's actually like super neat, and it's quite fast, and it's actually also inspired by some Rust implementations, and it's working like on all the environments, either Windows, Linux, and Mac. That's not a problem to run it. And I really like it because it's quite fast, it does not have a lot of overhead, and you can visualize things and so on. So I'm using that for my load test. And then actually, we'll jump back to the slide. Oops, here we go. I measure the build. So if you think of measuring the build, you will actually realize if you run a Maven build, that at the end, Maven tells you how long it took to run the build. So this is why I'm just parsing out the total time of the whole thing. And of course, you can also like then do something like Docker images. You grab for the image produced, and you get the size of the image. So we have already like two measures. Like one is like the building time, and the other one is the artifact size. You might see some strange \033 square brackets OM. I'm using that to make my logs a little bit more colorful. That's the only thing behind that. So I think I see things visually faster than just having everything printed out in black or white. Then when I measure the startup time, you can actually go and start your Spring Boot application, and your Spring Boot application will tell you how much time it used to start up the whole thing. So that means like you can also parse that out if you want to. And you can wait maybe 10 seconds, or maybe you're polling Docker logs. That's also possible, just to wait until this line pops up where it says like application started, and it gives you the timing you can parse and then also like convert. So that's kind of like the measuring thing. So because if you have a long running process, how do you know the application has started? The application needs to tell me, and that's basically in the logs. What I also measure is the memory usage after startup, because I'm interested like how much memory I immediately use after startup. And there I just use the docker top command. As we have seen before, we are going for the RSS memory, basically like that's the memory which is used by the container. And yeah, that's basically that part here. So that would be like how to find out afterwards. Then I do a warm-up. Of course, I mean, if you want to compare the application, we know the JIT compiler will kick in. And I just make some stress test on the application, on an endpoint, or maybe on a random endpoint, and just make sure that the JIT compiler has like optimized my application totally. And this is something where I just run the whole script like with 60 seconds. And you see I'm using OHA. I say no UI at all. I disable keep alives. So that means like we make sure every request gets a new connection. So that's more like real life than just like running the test from like one single machine. So that's why I have the keep alive there. And then I want to have like the JSON output at the end. These are just the commands. Well, we'll see them probably also like later, depending how much time we have. And then you can see that. And of course, if I would run my test suite, I can do that also afterwards. You really see the output. Good. And then, of course, we do the load testing on the whole thing. And this command is a little bit more complex because I'm parsing with JQ like the values within the JSON document which is returned. So I can find out like how much is the throughput, how much requests per second I have, and some more information. Okay. And then, of course, just right after the load test, I want to see like what was the memory used, so I can do that. Of course, I could also like measure over time, but that's just a bit more work to do. Great. And then some commands to clean things up, but we don't have to dive into that. That's not important, but for me it's important to make sure if I'm building containers, instantiating, I always have a fresh one, and I don't use like old ones which maybe are slightly different. If you are doing load tests, I mean, you can use this OH8. You can also use JMeter. In my examples, you will find like a way how I did that with JMeter. There is a nice Maven plugin, so you can even do it in the pipeline. And on the other hand, you can also use Gatlin, and there is also an example for that to go like through scenarios for do some load testing and get some charts. So that might be also interesting if you do like some load testing. Just saying. Good. So let's jump into the whole thing. So if you are talking about the baseline, if you go to start Spring IO, is still like Java 17. So You create a new Spring Boot app, they just set it to Java 17, but we know it's possible to do it like with Java 21, with Java 25, but let's also use for our comparison Java 17, just for the purpose of to see differences. The technology stack of the Spring PetClinic is basically Spring Boot with the current version, 3.5.6, since yesterday. Test containers, and then we have some migration scripts in there. We have some caching as well, and yeah, that's basically it. And it uses a database, a Postgres database, if you start the application by default. We are going to look at the things as I showed you the commands before: build time, startup time, resource usage, container image size, and the throughput. So, very important to understand is, like in this kind of deep dive, I'm using Buildpacks because it's already built in. Who of you knows already about Buildpacks? Who is writing Docker files? Well, probably the other half. Great. Great that you know Buildpacks already. I like them a lot because they help me to do a few things. They help me actually to make sure that my applications, doesn't matter which stack I'm using, the containers are always built in the same way. You probably know if you do Docker files, you have the issue that every team who has its own technology will do their Docker files in some different ways. And your Docker file actually might have some issues in there just because you don't know. So Buildpacks use best practices, and they build highly secure containers. They're maybe not optimized to the last detail, but they are nice because I, as a developer, I don't need to know about how to build containers the proper way, right? Okay, so fun fact, if you are going to like start your application and you'll see something like this on top, then you know the container was made with Buildpacks, because that's basically the output from the Buildpacks, which is visible, right? So just because we have time and we want to see things a little bit in detail, hey, not sure why when I press escape the Windows menu is popping up. Some really strange behavior. Yeah. Huh. Okay. Looks like my WSL just died. Let's start it from scratch. What's going on? Let's hope for the best. So, yes. Okay. I will make it bigger in a second, like this. So, I will just run the build. MVN spring boot build image. So we'll see the image, and I skip the test because they just take too long. Basically, it's just like wipe coding, right? Yeah. So run the build now to produce a container, and we will even see like the Buildpacks doing a few things when we're running this. Now it's like kicking in. It could restore already a few things because, of course, I have downloaded the Docker images already before. But you see if this is happening, the Buildpacks are doing a few things here. So they are doing adding CA certificates, they are adding Java to the container, SIFT for SBOM is there. It recognized that it's a Spring Boot app, so it has a fetch jar, it needs to explode that one with the dist zip. Then we have like the Spring Boot build pack, which does some more things we'll see later. So it just recognizes it's a Spring Boot app, and it tries to set a few things up. It's restoring here already some layers because they are probably already there, and also like from cache, as we can see. And then you see also output here, which shows us some settings and environment variables and so on. So I have been going through now the whole thing with the different steps, as you can see. And then actually, like at the end, it's creating me the layers in the container, as we can see here. That's super nice. And if I start my application, it will just copy this part here. Here we go. Docker run. So the application starts. And you will actually see on the top, which I said before, so I can zoom in a bit more, there is something called the Java memory calculator, which will do already some calculation of my heap, which is actually quite nice. So this Java memory calculator, which is built in, every time if you run your container, it will detect like how much memory is available to your machine, and it will use a calculation algorithm to size your memory for the container or for the JVM, because you should not have like 80% of the RAM used, which is provided to the container, because the operating system and the JVM also like needs some space, right? So you see also some other parameters. Native memory tracking is there. Certificates are added to the trust store. So if you have certificates in the container, they also needed to be added to the JVM, so you can call out. So that means with Buildpacks, you could even provide your own certificate authority, and it will be added like to the container when you start things up. Spring Cloud bindings is enabled, which means basically liveness and readiness probes when you are in a Kubernetes setting. This is just like detected when you run the application. And then you see here Java tool options with a lot of parameters which are just like calculated from above, concatenated, and they're used to run the application. So interestingly, you will see, for example, that there is something called exit on out of memory error. And I like that quite a lot, because like this line means if the JVM realizes there is not enough memory available, it will just like kill the process. So you don't have to wait until the OOM killer from your OpenShift or Kubernetes instance is basically like killing the pod. The JVM just will die, and then the platform will reschedule the container, which is actually like super nice. And you don't even have to think of that, because it's just built in. Of course, we have here some memory things as well, right? We also see some statistics and tracking stuff, and the Spring Cloud bindings, which is enabled as well here automatically. Another advantage you should be aware of, the process never runs with a root user. So they use the cloud native Buildpack user actually here to start the Java process. And a lot of examples you would find in the internet, actually in the Docker files, would actually just use the root user of your container, right? So that's why. So you see, it's quite nice here. And if you start your application, you will actually see how long it took down here, right? Started, PetClinic application, 6.2 seconds for the whole thing. If I press Ctrl+C twice, you will see there is more output, and this is kind of like the native memory tracking which happened here. So after shutdown, you get some statistical information about your JVM. You might need that, you might not even look at it, but Buildpacks just do that for you. So just like additionally. So this is like how Buildpacks produce that, and we don't even need a Docker file, right? So I think it's quite nice, it's quite easy, you don't have to care, and you just get the best container. And on the other hand, if there is actually updates for your run image, it will immediately fixed by the community, and you don't have to like maintain that yourself. We can have a look at Docker images here. I know there's a little bit more than that, because like everything I do afterwards needs some more. But you will see here, we have some run image. They got updated like 4 days ago. which is quite nice. And even like the tiny base image with Ubuntu Jammy has like 22 megabytes. You have here a Alpine Linux, for example, which also got updated 4 days ago. And even the one on the top actually is just 10 megabytes as a base image, which was just like updated a day ago, right? So I was quite surprised when I saw that the Bellsoft containers and builders and so on got updated just recently, which meant also like some of my tests actually like behave differently afterwards. But yeah, that's life on the bleeding edge. Great. So that's about the Buildpacks and how it looks like and summarized basically here on the slide. We just have been going through that. So you could say, I believe, Buildpacks are 1,000 times better than your regular Docker file, right? And they're more secure and maintained by the Buildpacks community. And also, of course, when, for example, Ubuntu does some updates on some libraries, they immediately get reflected in the Buildpacks, which is also quite nice. And you probably know this person here. He had a very nice quote, I think probably like 2 years ago or so. He said, "Friends don't let friends write Docker files because Buildpacks are so much better." And I totally believe him, and I think also the same. Of course, there are some challenges if you want to customize certain things, but in general, it's a very nice and handy approach. So, let's dive into the benchmarks. What do we measure? We want to measure build time, image size, startup time, memory usage. We want to measure throughput and latency with the following parameters. Be aware of that the containers I'm running just use by default 2 virtual CPUs. So I restrict that to 2 virtual CPUs. I know it's generous still. I have customers, they believe like a container should not have more than like 250 millicores because they're idling quite a bit. So, but that's not like the resources you should give them for startup. It's more like maybe the resources consumed throughout the runtime. And 1 gigabyte of RAM is more than good enough for the PetClinic. So that's basically like the constraints I do on the containers. Good. So let's have a look at the first part. Let's make a baseline. So the baseline actually is just like the Spring PetClinic. I would run it the same way as I did before with this mvn spring boot build image command, create the container. We'll start the container and do like all the measurements and put also some load on the application. As you can see, I used the little clock on the left side for the Java 17 because that's always the thing I'm referring to. And yeah, that's basically it. So after like running the whole benchmarks, you would get the results like 105 seconds build time. We have like 278 megabytes of image size for the container. We would use a startup time about 8.2 seconds, which is actually quite long. If it would have more CPU, it would be faster, of course. We have some initial RAM used. We have throughput of almost like 90 requests per second. Then you see also like the RAM actually like peaked. And then we see the percentiles for the throughput or basically like the latency for the percentiles. And what you can see is basically 99.9% of all the requests get through in 2.5 seconds. That means including the peaks, right? So, so that means probably the 99.9 is not like the regular case, but it's definitely like the worst case scenario. Good. So let's have a look at some other Java version which is out there. Of course, we could actually use Java 21. And we are just building the whole thing again with Java version. And as you probably know, when you're building your Maven application, then you can just specify the parameter here. And you just would override the Java version which is specified in the POM file. So I did that here. and I'm just running it for the JDK 21, and you will see some slight differences. I'm building it with the JDK 21, so that's why I say here I use Java on that version with SDK man, because then I can easily switch between the versions. And you see build time is roughly the same. The image is slightly bigger, because Java is probably a little bit more heavyweight. The startup time is slightly faster, just a tiny bit, of course. We have like the memory usage, which is like roughly the same, but we got like way more throughput on the whole thing, right? And also like the latency is, well, definitely like in the same ballpark, but you see like Java 21 looks like in the middle a bit better than actually 17. Great. So we get to that back later. I just also used the whole thing with Java 25 because it was recently released. Makes sense to use it. And then you realize, oops, yeah, certain things are better, but certain things are not better. As you can see, it uses like longer to build. It has a bigger image size. It's using more time to start, just like half a second. Slightly better initial RAM usage. Then we have like less throughput, basically. And you see also like RAM afterwards, and also like the response times are, yeah, about the same, kind of, at least like on the upper side, right? So how is that? How is that Java 25 compared to Java 17 is, yeah, not like on all the sides better? I have to tell you, and I see this already like since a few years, that the micro version for your Java distribution at the end really matters. So if you have a .00 release, actually you realize they ship the product, and then afterwards with some updates and improvements going on, it gets better over time. The same we see also like with Java 21, where we have the micro version of 8, right? And therefore, yeah, it's not like the first one anymore. And 25, which was just recently released, will probably also get better over time. And also if they do like some backporting on some improvements and do new builds, it gets better. So this is like what I have seen with other versions. If it was like 22, 23, 24, you really see that it takes some time and the LTS version like improve. So it's very important that you always go like with the new ones. Yes, there's a question?
Did you compare 21.0.8 to 21.0.0?
I don't have the data like in parallel. But like what I have seen over time, it really gets better. So that's really the case. You saw that with Java 17. The more micro version it has, the better usually it gets. So the thing is, if you use Buildpacks, you will automatically get the latest Java version installed. You don't have to like specify it explicitly. Then you are basically on the safe side, right? But be aware of like doing all the updates, not just because of security reasons, but also because of performance reasons. It really matters, right? So it's probably like our software. I'm just assuming. I don't know like the process which is behind the OpenJDK and the other vendors actually like building this. But yes, you have to ship the initial product, you get user feedback, you improve over time. There is another question. We'll get there. At the moment, not. So there is no optimization at all. It's no virtual threads. Yes. So we get there. That's like one of the optimizations you will see later. So that was like the initial idea. Let's compare the different Java versions. And you just like run that. And of course, the question would be like, how do you make sure that it runs on a different Java version? And how you create the container from a different Java version. Now let's jump back actually to the build we did before. And we save some time. We just have a look at the same logs again. So here, yes. So here is the line. In the Buildpacks, it's going to check for the manifest you're building your Spring Boot application in the fat jar. In the manifest, it's written which JDK is used, and according to that one, it will just use the Java version, which is quite neat. So you're building with 17, you get a container actually with Java 17. Of course, it has to be like this. We know there were lots of changes basically in the packages. XML got removed and these kind of things, right? So that makes a difference. So you cannot easily run an application which was built with Java 17, always like with 25. Of course, if your application would allow that, that would be possible. But what they do is they just use the same Java version you build it for, and then actually like they add it to the container. And that's basically like what happens down here while downloading now the distribution for Java 25. And it also detects if a JDK is needed or if a Java runtime is just good enough, right? So that's like how I would do that. I would just change how I built the application, and then you get a container which has already the new Java in there. So very small adjustment, just change Java version in your POM file. That's basically it. Good. So let's have a look at some more optimizations then. You could actually do something, and you could say, I do some tricks. And one of the tricks could be like, let's use no verify. I know it's very an ugly trick because you are basically turning off some validation of the classes loaded. But if you have to be really fast, maybe it's just good enough, right? And if you think of that, and I just jump into IntelliJ, and I'm going to run the PetClinic here, you will actually see they do a few things there too. So if they're running your Spring Boot application, you click on the 3 dots, you will actually see they do also some optimizations here. They don't do the no verify, but there are others we are just coming back afterwards. So we'll see that too. So no verify could be something which is nice for functions or so. And what you can see is basically we're just saving like 1 second. But of course, it's not secure. You should not do it, you know. And it might get removed as well. But the thing is, it just starts faster just by providing this argument. And now you're seeing also like a thing I do. I pass to the container an environment variable which is called Java tool options, and Java tool options enhances basically like how the JVM is started. So you just add the parameter to all the other parameters which were calculated by the build pack. So that's the idea here. And you can see throughout the different Java versions, it's faster while loading the classes, and you get definitely like better results, right? So this is like an idea. And I think, but I'm not 100% sure, but I think even Eclipse used to do that in the past. If you ran Eclipse, you started Eclipse as a process on your environment, it was using no verify so that it started faster. Okay. Now, Java 25 introduced a feature which is called compact object headers. You probably have heard of that. And at the moment, as you realize, we're just playing with parameters in the JVM. With use compact object headers, you just can go and basically like reduce the address of an object, and it's smaller. So therefore, we expect, or the main idea, let's say it like this, would be like to expect 10 to 20% more memory, right? Saving memory. So I didn't see this data, but you can see like if you look at the Java 25 on the lowest line, that by adding this parameter, we saved compared to the regular application, and I just copied that from the slide before, basically, we just saved a few megabytes of memory. So having these compact object headers saves memory, and that's the goal. As you can see, it leads to not better numbers, but maybe they're just like good enough for you. Who knows? I also expect that it gets better over time as well. But I think we have to ask the Java folks who know a bit more about that, like how that will change, or maybe the PetClinic as a web application where I just do some load testing is maybe not the right use case. Right. Okay. But at least like the idea would be to save some memory for your application, and that's possible, as you can see. Yeah. It's actually also surprising here, the startup timing improved also by half a second. So yeah. Again, be aware of, my numbers might be not always 100% correct. I usually just ran the numbers or the benchmarks like 5 times. I remove the peaks and I average the data. So it could be that they're maybe like slightly off. So if they are like within 5 to 10%, I would say they're still like very, very similar, right? Otherwise, I would have to run the benchmarks like 1,000 times to get like better numbers and to have like a converging result. Good. Another idea, just because we saw that before in IntelliJ, they are for developer purposes, they say like we use tiered stop at level 1 when they're starting our Spring Boot application. I did not ask for that. IntelliJ just does it. So what does that mean? What does it do? I find it fascinating to see it here. And probably for the use case of running your application in the IDE, it's a good idea. What do you do with this tiered at stop level? Basically, you're influencing which JIT compiler is used. By setting it to tiered at stop level 0, you basically define the thing that no JIT is working. So bytecode is just interpreted. By setting it to stop level 1, you're saying C1 will be used. So that means like you're disabling the default, which is in modern environments anyway C2. So C1 actually is optimized for fast starting applications, but it's not monitoring things, so the JIT is not improving over time. It's just like at the beginning, it tries to do the optimization and then it's done. It's not monitoring your calls, it's not optimizing your code over time. You don't have like overhead while the JVM is measuring what and how to optimize next, right? So with this tiered stop at level 1 in IntelliJ, it's absolutely perfect because me as a developer, I'm the only person using the application. I probably don't do load tests like from an application started in the IDE. I don't need optimizations. It just needs to start faster so that I get a better user experience. And that's what they do, right? If I do things like in my Java application, which goes to production, now you could say if I build something like functions, I want to start fast. I throw it away afterwards. There is no optimization needed. But if I have a long-running process, I'm heavily interested in the optimization by the C2. So, and that's actually like what you can see here in the numbers. We can really get our application startup time down by 2 seconds, which is kind of impressive, right? But then, if we look at the other numbers, and that's why I was a bit surprised, and you probably understand why, because I would have expected actually like the latency gets worse, because there is no optimization anymore, right? But the numbers just don't show that. In the past, the numbers showed like this, that it got worse, but now this time I have no idea why it looks better. Probably I have to like redo the benchmarks again, but I would definitely expect that the latency basically gets worse. So even like the throughput got better. I don't know like what happened here. Fun, right? But it's just an example I'm showing you here. I did not like make up the numbers by myself. I just copy them from my spreadsheet into the slides, and that's it. So, surprise, surprise, can happen. Another idea would be, let's think of the garbage collector we are using. Typically, in a Spring Boot application, when you don't specify anything specific, G1 as a garbage collector will be used. And you could say maybe a web application is probably better when you use like a garbage collector which focuses on high throughput. So high throughput garbage collector could be like the parallel garbage collector. And I was surprised to see this kind of thing also like in base images which contain like Tomcat servers. Not talking about embedded Tomcats, but like the Tomcat server. And Bitnami had images in the past which used by default just like the parallel garbage collector. So I thought maybe that could be an optimization step too to change the garbage collector to parallel GC. I did so, and what you can see is basically that the numbers are more or less still like in the same ballpark for my application, right? So I assume Java 21 got slightly better, but 17 is like highly optimized. It's basically the same. And Java 25, we would have to compare it against the same numbers, but I think it's Java 25 is just like starting up faster compared to before, but throughput is not really better. Yes. So this is something you can play with, just like with this idea, having high throughput optimized garbage collectors, which lead usually like to shorter pause times, and therefore the throughput gets basically like better. Might mean like because of like the wait times that the latency goes up a bit. Okay, so this is another optimization, and of course now in Java 21 and above, you could use like something like the Z garbage collector, which is meant to have even lower pause times, and which are basically like restricted to like 10 milliseconds. And as you can see here, I used the Z generational, which was meant for 21 to select it. Now in 25, that parameter is not needed anymore because the generational Z garbage collector is like the default, right? And yeah, now the numbers look slightly better than before. I would expect, and that's what we clearly see, that we need more memory. Because like we have shorter runs for the garbage collector, and therefore the memory is piling up basically, but it does it continuously. So that's what we see. We need way more memory. But what we also see like in Java 25, we are back to like the 80 here. We have like here with 21, also like more throughput. Yes, that could help. So you can play with those things just by adding a parameter, basically like to your Java tool options, because like your build pack is so flexible to change things. Great. So because there are like thousands of different parameters out there, I highly encourage you to have a look at the VM Options Explorer, because there you can find out if your JVM distribution you're using is supporting the parameters, because they're not all the same. Some have like different parameters, and this is just like a current screenshot from the website Chris Who Codes, who has this VM Explorer, and as you can see, there are plenty of different Java versions on there. It could be that right now 25 is there already, but when I took the screenshots like 2 days ago, 25 was not mentioned yet because it's still like too new. But that means like you can look up the thousands of parameters which every single Java version has, and also like by the different distribution providers. Maybe jumping back here. Oh well, where were we? jumping back shortly, because I wanted to show you why I'm using actually like Belsoft Liberica as the default JDK. It's because the Buildpacks by default are based on Belsoft Liberica. So that's just an open JDK distribution from Belsoft, and basically like VMware Tanzu, the company behind Spring, they worked close together with them. So if you would have like support on VMware Tanzu for Java, it would actually go through Belsoft. So that's why in the Buildpacks, by default, the thing is Belsoft Liberica. But we'll see, we can change that easily. And I'll show you later how, if your favorite distribution is something like Eclipse Temarine, or you want to go with OpenJ9 and others. Okay, just wanted to explain that. And because like there are so many of them here on the page, we can actually choose them and use even like Amazon Corretto or whatever you want inside your Buildpacks. Good. So let's have a look at some Spring Boot optimizations, and let's try to get some ideas. So one idea could be, let's make the Spring Beans lazy. And the Spring Beans, to make them lazy, you would either have to put like the @lazy annotation on your configurations or on your Spring Beans, or Spring Boot provides you like two parameters. One is like more general. You see here Spring main lazy initialization equals true. So that means like Spring Boot only sets up the Spring Beans which are needed and will like initialize all the others while the application is running. Or you could actually say like the first request gets super expensive, right? The second one, which is related in this case because the PetClinic uses Spring Data JPA, I'm like lazy initializing JPA. So you probably know it takes quite a while until Hibernate and therefore also Spring Data is initialized. And so I just turned it off. So my goal in general is just like to have the application starting fast at the expense of the first request. You won't see anything like related to these numbers in my benchmarks because I have a warm-up phase. And in the warm-up phase, all the beans needed were created. So the first request was damn expensive, right? So that's why you don't see this in the numbers. And it still like behaves like very, very similar, right? But what we can definitely see is that we almost saved like 1 second for the startup time. So the question is like, yes, is that necessary? Or can we deal with that? I mean, also like deferring the feedback to later, is this a good idea? Or do I probably want to have like faster feedback when the application is started, something is misconfigured, it just should crash, instead of having like the exception on a thread which is serving the request. So you have to ask the questions yourself, but I just wanted to show you, hey, if you want to optimize just for startup with some drawbacks, we can do that defining like some lazy Spring Beans. So as I said before, there are definitely pros when you want to have faster startup and when you want to make the startup cheaper and then actually like make sure the application is initialized on your own. But then also like the cons where we definitely have the feedback later and where the exceptions for the initialization will happen actually like on a different thread, which is definitely also like a bad thing. So be aware of this. I came up with another parameter. Probably you know in Spring Boot there is the possibility to have like YAML files and property files in different places, inside and outside your Spring Boot application. So that means what I mean like inside the fetch jar, but also like outside on the file system. So Spring Boot, while starting up, checks for like 4 locations where your property files and your YAML files can be. And if you don't want to make sure that it checks like for all the 4 possibilities where the files could be, then you could say like, here is the file, that's the only file, You don't have to search for things, right? It's just like that. And that's what I do here with Spring config location. And it's a little bit weird how I do that here, because I pass it, oops, come on, here. I pass it as an environment variable with the dot notation. So you are probably aware of that if I would pass an environment variable, it should be like all uppercase with underlines, right? So like screaming snake case. But I did it with the property syntax, with the dot notation, and even I would have like the dashes in between for the camel case if needed. But the thing is, Spring Boot can deal with that. So if I pass an environment variable which looks like a property name, Spring Boot will deal with that, and it will translate it anyway to like all the other variations. And therefore, I just can do it the lazy way. I just copy it from the documentation, put it in here, and I run it like that. So it's just like me being lazy and not really writing the uppercase and underline expression way. So the idea in general would be here that it starts faster because it does not need to look up things, and then you should have the same results afterwards. And you see there are variations, right? Because like I did different runs, so you see like how Java 17 is even like fluctuating with the results. So they're like all in the same ballpark. I think that's still good. They're very close to each other, but we clearly can see like the startup time get better. Great. So now let's get to another thing. Let's do something like no Spring Boot actuators. And I will afterwards then change to the IDE so we can have a look at how we could build that to easily find out like how many Spring Beans are loaded, because you will be surprised. You think like actuators are something which is nice and easy to use. It's kind of free because it's just a starter we add, but it comes at an expense. So what you can see easily is that if you're using actuators, then you will have like 463 Spring Beans in your application context when you started your application. If you remove the actuators, it's just like 283. So you could say like, there is a difference of 180 Spring Beans, and it's quite a lot. Sorry. I'm actually even looking forward to Spring Boot 4, because like in Spring Boot 4, they will have different auto-configured jar files for all the different starters. At the moment, we just have more or less like one big auto-configure file which contains all the auto-configuration like for all the supported starters. And like with Spring Boot 4, they will do some better modularization, and that means like we will bring the Spring Beans loaded also even more down. So like the 180 difference. So how would you do that? I mean, that's like an easy thing to do, right? So I just open up here my adjusted version because I do the printout. And since typing is a little more difficult today, I don't know, I just have like prepared the whole thing. So you can actually see it's super easy because Spring application run returns an application context. You just go there and ask for the bean definition count, and that's basically it. So you know, like, as soon as your Spring Boot application is started, that many beans are part of the application context. And if I run it, then you will actually see how many are in there. And I think I did that here as well. So we started things up. And here are the 463 Spring Beans just printed when I did the previous run. So you see, Spring Beans, creating Spring Beans is also expensive, and I would try to avoid them if possible. And if you don't need actuator, then why not just like make sure it's not part of your application. But of course, actuators are great. They also bring us observability features. And I'm not saying you should leave it out, But there are some cases maybe where you run the whole thing, for example, as a batch job, your Spring Boot application, and you have accidentally actuators in there, you will see that your batch job is actually like running slower. Yes, there is a question?
They also make all or some of those actuators lazy while the rest of the application is complete.
I mean, you could actually like turn off some actuators. There are flags for that individually. You could actually use something like enabled false or so, and that would be possible, yes. But that's not the auto configuration part, yeah.
Yeah, but I do want them for observability purposes.
Yes, of course.
Don't need to be started loaded when I start the application. They can be delayed until I query.
So you want to make the actuators lazy. Well, the infrastructure still, like for observability features, has to be in place. So that means, like, for example, your REST template needs to be changed so that the tracing headers get added and stuff like that. So certain things have still to run. It's not only about the controller which exposes the endpoints for the actuator.
They can then also be virtually loaded, right?
The REST template, for example, if you build a REST template, you always use the builder, because auto configuration behind the scenes use a customizer to change it. And as soon as you do REST template.build, the template is instantiated and it won't change anymore. So that's just like how Spring Boot does it. It's also the same for the REST client, for the web client, for all these kind of things. You always have a builder pattern, and you need to call build to create the client, and then it's basically over. It won't be changed anymore. But it could be definitely interesting, like what you could delay and how to do that. And if some infrastructure can be set up like during the first call if needed, of course. Yes. But that means like you have to dive deeper into Spring Boot, and you would have, or we would have to see like what is feasible to turn off, or maybe like replace it by some manual written code, or code written by our own, like custom code. Yes. But I just wanted to show you, I mean, make sure that you only use the things you really need, because it's also expensive. Great. So let's go now to another nice part in Spring Boot, which is called the ahead of time compilation, right? So I'm just jumping into the example so I can run it, because I made sure before my workspace here is clean. And while I'm running it, AOT, and we just use the 21 version, doesn't matter. Then we can actually like see what's going on afterwards. So MVN, Spring Boot, build image. So the AOP part, the AOT part, ahead of time compilation, is the idea that we are basically like replacing things which are dynamically detected during startup. So imagine you do component scanning. Imagine you do entity scanning. You're using profiles. You have conditional annotation in your application, or actually also Spring Boot has them behind the scenes. Earlier, there was a project, and you see that referenced. It was called Spring Context Indexer. So everything you did component scanning on was basically like placed in a file, and during the startup, when the file was present, it did not scan. It just like loaded that file. And that got deprecated, or got removed actually, like in Spring Boot 3.2. So the replacement is actually the thing called AOT, which is used also for native images later. So what does it do? I'm running the whole thing now. Oh, I guess I'm running the tests now. I didn't want it to do that. Yes, so they skip tests. So it's running AOT now. A second, I guess. And it's generating additional files. So there is like the thing called process AOT. I'm just jumping in my IDE, and yes, and we just have a look at the 21 here, and you will realize in the POM file there is a small addition to be done, because we have to scroll down here to the build part. That's the format plugin, check style. We get there. Right. So one part is actually like that we say execution process AOT. So it's a separate step with the Spring Boot Maven plugin. And another thing we need to specify is for the Spring Boot build pack that we say we want to have AOT enabled. I'll just show you in a second. So the last part is the thing that if you jump into the target folder, you will realize there is a Spring AOT folder. The Spring AOT folder consists of different folders, packages with files in there, and I'm just opening my ones here. And I just pick a random one like the controller, and you will actually realize that the AOT does what basically like component scanning would do. It's registering the Spring beans in a very generic way. They use the underlying infrastructure to register the bean definitions. So we can see here clearly my controller is part of this root bean definition, and then basically like it gets registered a little bit more above in the structure. So if we think of like when you have a look at the application class, you see here some really like fancy things which are happening. So it's really like low-level code. So the AOT step basically creates this low-level code that there is no class path scanning going on anymore, right? So what would we expect? We would expect when this is like compiled and we run that it runs faster. Now the thing is, of course, these additional classes created, they're also added to our application. They're also added to our build pack. And just like scrolling down, and let's run the application shortly. And we will see my build pack, docker run, just like do it like this. You will see here in the build pack, there is a parameter called Spring AOT enabled. So if you don't set the Spring AOT enabled, it will still do the component scanning. So that's super nice during development, of course, but afterwards, when you go to production, you want that in your container, and you want only to read those or to register the Spring beans from those classes. But be aware, running AOT means you need to have the profiles loaded while you're running the AOT step. So it needs to be the same thing, which leads to the bean creation. So if you have like a development profile and you do not create all the beans in the development profile as you would need in production, the production beans won't never show up if you enable AOT while starting up. So the profile evaluation is actually done in this build process, and the classes are only created once. If you have properties, like for example for the database name, for username, password, and so on, these values still can be different, right? For test environment and production, that's not a problem. But you need to build the AOT on a production configuration-like thingy. Just you don't want that maybe you call out to the database from the build pipeline, right? But you need to make sure still like that those things are there. So that might be a little bit tricky if you start playing around with AOT, that you have to think of it needs to be a production-like environment. Okay, so what we just have learned is we just set the process AOT that these files get created. They're created on the fly, and then we make sure that the Spring AOT enabled is set to true when we start the container, right? And that leads definitely, as we can see, to faster startup times. Everything else, I would say like it goes into the same direction, right? Because when the beans are there, you run the load test, that there should not be like a huge difference. but the startup time will definitely like improve. So that's the idea here. Great. This part is like more fun because imagine if you run your application inside your IntelliJ and you're looking at the parameters here passed, you will be surprised. So they use JMX here. So JMX is enabled. They are reading ambience for things. For what? For the parts here. So if you go and see like which Spring Beans are part of your application, then actually like the ambience are read via JMX in your IDE. You see also like my health endpoints. It's enabled, so it's visible, right? The mappings, even my environment, all these kind of things show up just because of the JMX is enabled in the IDE. Of course, I don't want that in production. And that's why I said this part is kind of fun, because you don't have to do anything. JMX with Buildpacks is by default disabled. It's also disabled by default, not only from the Buildpack side, but also like from the Spring Boot side since version 2.2, so also like very early, right? But if you just have seen that in IntelliJ, you might ask like, how do I make sure that JMX is not there? Because that would mean like more infrastructure, more slower startup time and so on. Right. So you see, I like Spring Boot, or I love Spring Boot, and Buildpacks, they're just like awesome. We can do things quite easily, and you will see like way more afterwards. Great. So let's talk about application optimizations. Application optimizations is a difficult topic because you are the expert in your application, and I can't tell you much about that. But what I can show you is, I can show you how to clean up your dependencies. I always say that starting a Spring Boot application with a starter is good because the starters are opinionated, but they are not meant to stop or finish the application, right? So you need to do the cleanup yourself. So how could you do that? I stumbled across a thing which is actually called the depclean Maven plugin, and it was done by a person in Sweden working for a university. He's not there anymore, but that was kind of his PhD thesis, I believe, or at least like in this area. And there was like a tool created to find out like what are the dependencies of your applications and which ones are used and which ones not. So we just could go here to my previous example. Let's do the clear. Let's stop it first. Clear. And let's just like run on the adjusted one. Adjusted means just like we print out the Spring Beans. Let's do on this one, because we have built it already, the dep clean. And you see I had additional parameters. Just show it again here. I have a parameter for the pipeline failed if unused direct true. So if a direct dependency is not used, the pipeline can fail. And I can also say like ignore provided scopes, or test scopes, or runtime scopes, or system scopes, and so on. But I just like run the full report, so we'll see how it looks like. It's a thing I like quite a lot, because, or that led to the thing that I fixed some things in there, because it's not working in Java 17 anymore, the 2.1 version. So I made it to work in Java 17 again with a contribution, but unfortunately the reason to be released would be only like a real feature. So adding backwards compatibility to Java 17 is not enough feature, I learned exactly. So now it's actually doing the dependency analysis, and it's way different than just like dependency tree in Maven. And you will just see like the dependencies which are inside the application, which are directly referenced. You see even here dependencies which are having test scope because I did not exclude it, which makes sense, right? Test containers. We have also like JUnit Jupyter as a direct dependency. We might have others too for testing. Then we have also like transitive dependencies. You see quite a lot, transitive ones. And now, which one do I need to use, right? And then there is another categorization like inherited direct dependencies, inherited transitive dependencies, potentially unused direct dependencies, because the dep clean actually allows bytecode analysis. So it checks like for imports in classes you have in your class path, and it can guess like which dependency is probably used or which one not. And it also checks for strings. If you do something like reflection, class for name, something like that, it will find those things. There are some drawbacks because like the tool is not optimized for Spring Boot, but I will tell you like in a minute or so. Then you see potentially unused direct dependencies. Of course, like the PetClinic uses Bootstrap, so Twitter Bootstrap plus font awesome. Well, it's not detecting HTML files, so that's why they are there. Makes sense. Then Docker Compose is not used, probably. Yes. DevTools, a few starters. You see the starters are quite small here with 4 kilobytes because a starter usually contains just transitive dependencies. So that's why we could remove the starters and not using, or we could directly use the dependencies instead of the starter because they are just like the POM files. So we see potentially unused transitive dependencies. And then you see, for example, something like, yes, that's one. The PetClinic actually does not have YAML files in there. So I could remove the snake YAML parser. Fair enough, right? I could do that. There are other things actually like related to that. We have some test dependencies, small ones again. Yes, probably. There might be a few more. So I would have to check also the things above. So it creates you a report for the things, and it took just like 17 seconds to create the report. I would not always do that in the pipeline because it takes 17 seconds longer, but, but you could actually run it from time to time. Yes, you can also create a debloated POM. So that means like without the starters, just like having everything on one level. That's possible as well, if you prefer that, and then you can start removing things. So what I learned about the PetClinic in my case was I could remove a few things which are in here, which are also listed in the report, which was, for example, unused database drivers. Or, for example, since I'm not using a REST endpoint at all, I could remove checksum, just because I don't need it. And the other thing is, which I found as well, was, have you ever used in your Tomcat or Spring Boot application WebSocket support? So there is a Tomcat embedded WebSocket jar file, which is there, but if you don't do WebSockets, you just can remove the dependency, right? So this would be an idea how to like slim down your application by a few megabytes, and you get a better understanding how it works. And of course, it's trial and error, right? Good. But you see, it's quite nice. It's a very, very small and easy tool. You can immediately add to your POM file if you like, or just like run it from the command line as I did below. Good. So that's the output, just like as a summary. So we'll have that for reference as well. And what we see here definitely is that we could reduce the builds or the images by about 6 megabytes. It's not much, but they were just like my initial ideas I had to remove. For the others, I would have like to test a bit more. But at least like 6 megabytes less, it's already better. So that means like my application is starting faster because I have less jar files to be loaded. That's also already quite a benefit, right? Good. And then of course, there is more application optimizations. And this is something I can't help you with. I can give you some pointers to topics like, yes, you can improve your algorithms. Use JMH to do measuring, right? Whatever. Think of your database connection pooling, because like that makes a difference, like how your application is used. Your Spring Boot application by default has 10 connections to your database because Hikari is automatically configured like this. Think of like using caching in your application. You know exactly like where you could save times, right? How to optimize your database queries. Think of the N+1 problem with Spring Data JPA and so on. Make some optimizations in your batch processing. Reduce garbage collection. Monitor and tune your JVM settings. Reduce overall memory footprint, whatever. And maybe even use something like an asynchronous logger if you log to files, for example, right? So that your threads are not blocked. So these are just a few ideas I can't help you with. I can't give you like a standard solution to be more on the technical side. That's the thing where I can show you some optimizations. Great. Before we dive into further JVM optimizations, I heard that yesterday some other people did some break. So I would love to do now a 15 minutes break, so you can grab a coffee, go to the toilet, whatever you need to do, and we will be back at 11:10. So welcome back. I hope you enjoyed the break. You had a lot of time to talk about like weird cases in your applications. I enjoyed talking to the people joining me, telling me things like what they like about some features in Buildpacks and what not. Of course, I may be a little bit too optimistic about Buildpacks, or maybe see just like my perspective, but you might have your own, and if you make a deliberate choice, and you know why you don't want something, of course, maybe it has a reason, or it's good for you. That's absolutely okay. I just realized regarding the DepClean plugin that I missed to tell you something. Because I said before, it's not aware of Spring things. So the DepClean plugin does not know anything about component scanning, entity scanning. It does not know anything about auto configuration imports, the file which points to auto configurations within the auto configure module, so they can be loaded and so on. It does not know anything about the WebXML, for example. So we just have to be aware of that, and we need to deal with that. So DepClean is just not a Spring tool knowing about all the Spring-like things. But as I said, it's definitely a good starting point with a good idea, mindset, what you have about your application. You can remove dependencies which are definitely not needed. Good. So let's jump to more optimizations. And now let's make some more fun. Yes, you want to ask a question?
Would it then help if you use the Spring AOT for that? Because then it's all, there's no magical scanning, class scanning anymore.
The question is actually like if you run the AOT part, that the magical scanning is not there. We have seen automatically it goes into the target folder, so I'm not sure if that will work. We would have to try out, but definitely for the component scanning things, of course, this will create references, or if you would copy the sources into your project from AOT, it will work, of course. Yes. Good. So more optimizations. Who knows about JLink? For me, it's like the underrated tool in Java, because you can customize your JVM. So think of that. You do something like this. I just have this on the slide. I will do some other things later. So JLink actually allows me to collect the modules in Java and to create a custom JVM. So what does that mean in the end? I get a smaller image. I get a smaller JVM, which maybe starts faster. It's optimized for my application. It's not just like the standard in installation. It's highly optimized, right? So why not doing that too? And now you will realize doing that in Buildpacks, it's basically just adding a parameter. Just say BP JVM JLink enable to true, and we will reduce the image size, and you can compare now Java 17 because they're like side by side. You can see like we saved about 90 megabytes just because. Wow. Of course, build time took a bit longer because you need to like unpack the zip file and remove the unnecessary modules, but that's the thing, right? So that's super cool. Just adding that dependency and the not dependency, but this environment variable for the build packs, and it will create you a custom JVM. And you don't have to do something like this on your own. And as you can see, also I'm adding additional parameters here. Maybe the question should be like, can I customize that? And of course, if you know things better, you can customize it. And I'm using here the tool which is called the JDApps tool. And I just can show you the whole thing like with JDApps. So I'm just copy the command because I don't know things by heart. And let's just go into the console here. And we just check shortly like which Java version we have. So probably we have to like adjust it. Okay, we have to, it's Java 25. So in my target folder, unzip, I have my target Spring PetClinic jar. I just unzip the whole thing because I need the dependencies from the boot inf directory. And now I have JDips, ignore missing dependencies, queue, I say here, I want to have release 25. And now I can go and calculate that for my current dependency. And I have to pay attention because I copied too much. I think that's the adjusted jar file, like this. So you could go and say like, let's calculate which dependencies within the JDK is actually used. And now you get the modules you need for your application, right? It's quite interesting if you look at those. I mean, Java base makes sense. We are still in the year 2025 when Java desktop is part of my web application. Come on, can't we fix that finally? It's the way it is. Let's hope it gets resolved because Java desktop is quite big. And I heard from the Spring team there are ideas to like re-implement certain things so we can get rid of the Java desktop. But probably it's a matter of time and resources until this is done, right? So if I copy now the output from these JDApps, I could now optimize my JLink, and that looks like this. So I can say I want to have JLink in my build pack. I just pass the modules with the arguments and just like listed them. And I say like I want to compress it. I want to have no header files, no man pages, strip out all the debugging things because I do not debug in a container. So that means like let's get rid of things. And yes, you will see it's roughly the same as we have done before because the default parameters are quite good. But what I wanted to show you is more like, yes, you can actually like adjust that. It's quite nice, I think, right? So shrinking the size of your images. There is another topic in the Java space, which is also quite nice. It's called like class data sharing. So imagine you are doing an application start. And when you do the application start, you just like snapshot all the classes you have loaded into an archive. and you load that archive when you start the application afterwards, right? So that means like you don't have to find the classes from your jar files and so on. So you really have the possibility here to dump things and restore it from this archive. Let me dump into the example. I think we use this one here. Yes. You also see here I have a version like with Spring AOT. I mean, with the AOT part and do Web CDS at the same time. So that's possible as well. But I'm just like going with this one here. And come on. And we skip the tests. So here we go. So the idea, in general, what happens behind the scenes. I just go to the slides back so we can afterwards have a look at how the logs look like. The idea would be we do a dump to an archive here. And the question is like, how can we do that? So the Buildpacks will start a training run, and we will see that afterwards in the log. So the training run starts the Spring Boot application. And then actually like there is an additional parameter added, which is called Spring context exit on refresh. So that means when the Spring Boot application is fully loaded, it just exits. And then the dump is made. When we are starting the application, it uses the shared archive file, and it will load things from there. So that additional parameter has to be passed. And that's also like something you will see when you're doing, or when you're starting the container, that this parameter for the archive is actually passed. So looking at my thing which happened here, let's just scroll up. So we do the build image. It found the things again, right? It added some Java stuff. And now it does the CDS. So CDS is part of the Spring Boot build pack. And so you see some parameters here. And it does a training run. It starts the application, and there will be an exit afterwards here. There is the exit is happening later. Yes, you see also like there is some CDS things going on. Lots of CDS things going on. Some things cannot be loaded, like proxies, makes sense. But AppCDS is very tolerant, so classes which cannot be dumped into the archive will be loaded from the jars at runtime. So it's very tolerant. There is no problem with that. It always works smooth this way. So that's great. So that's why we see here proxies created. There is an unsupported location because the proxies do not exist, so they won't be dumped, and the proxies will be created at runtime. So it's just a way of faster loading, actually, like your jar file. And this is actually what happens here. Now, of course, when you're adding the layers, you need to make sure that this additional parameter gets added as well. And just a second, I'll do it like this again, because we have different names. So Docker run, and we just start it up, and we should now see that it's restoring from an archive. And wow, well, it says it should restore from this one here, but because of reasons, unable to use shared archive. It's not using the same compressing way of the things. So I should log it and should find out like why that happened. Okay, that's now a surprise. Usually it doesn't say anything like this, but if you do something like this compact headers for objects, for example, that's the same issue. So if you build it like, or do the training run with the compact headers, and you restore it afterwards without the compact headers, you will exactly see the same. So now we have an issue with the with the way the classes are stored. So that's why it's not loading those, and it's loading the regular application. So yeah, I'm not now debugging into the details what's going on here, but I think you get the idea. So the parameter got added, and things should be loaded here, right? Yes, good. So that's it. So in the end, what we would expect is actually faster startup times for the application, just because we have this archive. So you saw, isn't it nice? We have JLink. We can do app CDS just like with one parameter. You don't have to script the things yourself. If you are doing Docker files, you have to do it manually, right? So I'm sorry for you, but Buildpacks is so much nicer. Good. So, yeah?
Sorry for yet another question. But that class data sharing, it was impressive how much from what the start time it actually took off.
Yeah.
But is this then something that you need to commit with your repository?
No, app CDS is actually like while you're building the container. So maybe I missed to say, if you look at the size of the container, it's bigger because we have the archive added to the container. So while building the container, we create the archive. But yes, it's impressive how the result looks like. Definitely good spotted actually here. Yes. So it's really like during the build. It's not part like AOT where code is generated, but that one is also only in the target folder, so it's not committed. This one also, there is no need for that. And you need to make sure that the same JVM creates the CDS like the one you use afterwards to run it. So that's why it's kind of in this build process it's executed with the same JVM. So now in my case, it could have been that it was not the same because of reasons I don't know. So yeah, but well spotted actually. Like yeah, it's like 3 seconds less or more than 3 seconds. Cool. So now you probably have learned yesterday that there is a new feature in Java 25 which is called AOT caching. AOT caching is kind of like the next version of app CDS for your Java. And it's part of the optimization efforts they do with Project Laden. So you could say AOT caching is kind of a way of app CDS, but different. I don't know the details, please don't ask me about that, what happens behind the scenes. I just know a thing that Buildpacks do not have support for that yet, but I'm still going to show you that I did it with Buildpacks, and that it works in a very similar fashion with the training run as you would expect from app CDS. So AOT caching should be way better. And of course, in combination with the AOT processing of your Spring application, these generated files which register the Spring beans like in a code way, it's even better. So there are even like charts out there from the Spring team where you have a huge benefit when you have like the AOT processing plus the AOT caching in place. So my point here is it does not exist in Buildpacks yet. So therefore, I had to do it on my own. And I did that. So I'll show you this. I just added to my project a thing called Buildpacks. Buildpacks is just a standardization which like basically alters one of the layers after another. And Buildpacks have like 2 phases. One is the detect phase, and the other one is the build phase. And I can make sure by specifying things that my AOT caching will run after all the Java stuff is done. So let's have a look. So first we have to find out if my own build pack needs to run. So that's something I do in the detect phase. So as you can see here is I'm just checking if build pack native is set to false. That's like one of the checks. And then I just don't want to interfere with cloud native images. And then I just create here a file for the cloud native Buildpacks build plan path. So I tell it actually like I'm depending on the JRE. So I need to run after the JRE build pack basically. And I can also do some logging. I can say, for example, AOT caching is running or not, so you'll see it in the logs. So detecting is just checking if and when in the order of the build pack things will be executed. I have done a script where I do now a few more things. So I create here, I do also some checks above first, and then I create here my layered directory. So like I have a directory where I put my things in there, which will be added afterwards to a layer. I check if Java is available, because that's really needed to find out if I have really like Java before I can do anything. And then I do something here, like I add I use my Spring command, java -jar. I have the class path on the dot, because that's my working directory. So I assume it's already exploded. So the build packs always explode like your application. So it's not a fetch jar deployment. So it really like unzips everything, because an unzipped fetch jar starts faster than a zipped fetch jar, basically. So that's why I say that's my class path, where all the classes are in there, and also bootinf and so on. And I say, when I'm doing the training run, there you see the training run with the exit on refresh, I'm doing the cache output to that file, which is specified above. And then I say, like, what's the class with the main method in there? And that's my jar launcher. So basically, like, we run the application in a training mode. As soon as Spring Boot app got started, we stop it, we dump the AOT cache into this AOT, or this app AOT file, right? Then I have to specify a few more things here. And I'm also, technically speaking, I'm adding the argument for the AOT cache, where I have the file later to the Java tool options. So this is actually like enhancing the Java tool options. Okay, so let's have a look at this one. AOT cache. I think it's just 25. Yes, let's use this one. And SDK. Let's make sure I have Java 25. I have that. So I'll do again Spring Boot build image. And also this step actually is running while we are creating the container. I missed again the test. I should have done that like in Maven Ops or so. Skip tests. So, so you'll realize in a second that when we run the build packs, we get there. This takes a while. At least it doesn't need to download all the build packs. Yes, awesome. So we see now something. So you see now I have added my build packs here in the list. So it's not like 6 of 26, it's now 7 of 27. And my build pack will be considered for the execution, right? And that means like after everything it was done, even like AOT processing and things would be like before, because that's part of the Spring Boot build pack. So now what you can see here is, yes, we are getting here. You see here that I have started, and I need to see, I think it's starting here. We are now recording the AOT mode. We're starting the application. You see how the Spring Boot app starts up inside the build pack. And then you will see some strange things here, like this AOT linked stuff and so on, like an AOT thread. Some mentioning regarding classpath and so on. Then actually also the output regarding the AOT cache for the Java tool options and so on. You see some more technical logs. I just made everything visible, so that's why we have so much there. Usually you wouldn't, but I find it interesting just to see there is something going on actually. So and now we have the container again. So the AOT processing just happened, and if I do docker run, you will realize that here we go. We have an addition to the whole thing, and we have added here the AOT cache layer. We point to the file, and unfortunately, I'm not sure what's going on. We have the same issue again. It's again the issue that something with the Java is not matching, and it just does not use it. That's a pity for the demo, but in my test it worked quite well. I did it exactly the same way, and yeah, that's basically it. So that's like how you would see this AOT caching. This is also something you just can do. It doesn't cost much. But of course, if you think of like your image size, for example, it gets way bigger because you have like things stored, but therefore you can like save 2.6 seconds in startup time. So as you can see again, it's a trade-off. You want to either to have like maybe smaller image size, but also maybe faster startup, but you can't have both. Great. But the question is like, what do you want to optimize for? And Buildpacks are also great because they can relink layers. So not like your Docker file, when you change a line in the Docker file, that everything below has to be recreated. Buildpacks can basically like relink and reuse existing layers. You can even like with one command just replace the base image or the run image without changing all the other layers. So you can leverage that actually like with Buildpacks, and therefore you probably don't have so much traffic on the network when you're like deploying a new version of your application. Now let's jump into other runtimes. So there is a thing out there which is called OpenJ9. Maybe you need to use the version from OpenJ9 or Semru from IBM as a JVM. They used to say they are like way better with the memory, or they are better with memory than actually like hotspot. Why not changing to this other distribution then? And of course we can do that. And now it gets interesting because we were talking about Buildpacks, and now I want to change my Java Buildpack. So therefore, I'm going to add a Buildpack for OpenJ9 here, which I specify. And because I specify OpenJ9 here, I don't have bells of Liberica in there anymore, but I'm using now OpenJ9 from IBM. And what you also see in the example is this kind of entries we have here. They are basically like Docker containers. And you can add a tag there. You can add a SHA, a digest there, if you want to. So I just say latest for the demo purpose, so I get always like the fresh ones. But probably you don't want that in production. Maybe you want to have that more like restricted. So the only thing what you need to do is you still have to declare the Java Buildpack. Because if you only specify the OpenJ9 Buildpack, you don't get like the Spring Boot Buildpack and all the others. So that's needed. So that's why I explicitly specify the Java Buildpack so I can inherit the ones which are defined in there. As you saw before, like the 26, right? They are basically like behind this one line for the Java Buildpack. So you can switch now the Java version, and you could do like benchmarks. And you see like with this approach, just with the defaults, without like optimizing anything, it does not get better. I'm not ranting about them. I could, for example, add some quick start parameter, which is like tiered at stop at level 1, or you can do something like virtualize as a parameter, and then actually like it's kind of in the same ballpark. This is just like default setting. I have benchmarks like with other parameters where they look better, but I just wanted to show like you can change the Java version. You can also use GraalVM, and I'm not talking about native images yet. I'm just talking about using GraalVM as a JVM, because the Graal JIT, which is not part of the Oracle JVM anymore, right? You can have it with the GraalVM thingy. So that's why you can specify GraalVM as your Java runtime, leveraging the Graal JIT, which is really better than the regular ones. So that's like how you would change it the same way like OpenJ9. And I said community edition on top because Oracle has their own distribution, which is a little bit more sophisticated than what you get like from vendors like Bellsoft, like from Red Hat and others. So yes. And you can also do something like the Oracle JDK. You just like add that one if you want to. So this is like how you would switch those. Good. Now, let's go a step further. And let's think of other builders. So Buildpacks use builders. And you can think of a builder like something which belongs together. Like the building part, but also like the run images, the base images, and the build images, and so on. And we could actually change that. So the question would be actually, why not changing from the default ones you have to like another builder? And why would you do that? Maybe your company does not like Ubuntu as a base image. So therefore, maybe you want to do something different. Maybe you have your own base images and maybe you create your own builder. It's not such a magic thing. And as you saw before with my build pack I did, it's not necessary to program in Go. You can also script things on Bash if you do not know how to write Go code. So that's why I did it in Bash, right? Okay, so changing now my builder would lead to like something different. And since we just have the possibility, let's check build pack, Paketo, builders. Here we go. I just wanted to show you like the list of builders, but yeah, that does not work. So even Paketo we used before for the build packs has like different ways of builders. Builders are bigger, smaller. There is like an Ubuntu Noble version. There is an Ubuntu Jammy version. You just can choose from. And of course, there is also with Bellsoft, they have their own builder because they do something. They say we have an Alpine Linux underneath, and that Alpine Linux is a little bit a challenge, especially if you like install Java because you need a special version for Java on Alpine, because it depends on the C library which is used behind the scenes. So Bellsoft created this builder which gives you like a base image for Alpaquita, which is like a tiny version of Alpine. And well, we just can have a look at the Docker images here. Then we will see like the different ones. Images here. Then you will see I have my build pack here for Alpaquita. So I have my run image. There is another run image. And you see with the tag, there is a muscle distribution. There is a glibc distribution. So on Alpine, it's always challenging, like, do you have glibc installed or not? Because default usually is muscle as a C library. You see also the difference The glibc distribution is quite bigger. It's 22 megabytes because it's quite hacky, I would say. And you have like the muscle version, which is usually smaller but nicer implemented. So when less hacks in there, and you see like the size is like half of it. So we can basically like choose which builder we are using and which Java will be installed as well, because Belsoft provides you different versions in Java depending on the C library below. We also see, let's search for the builder here. There is, for example, the builder Noble Java Tiny. Builder Noble Java Tiny is the default for Spring Boot right now. And you see the builder itself, it's quite huge. But we will use for Noble the base image, which is also only 22 megabytes. So that's my image to run the whole thing, right? So it's kind of comparable to the glibc version from Belsoft. There is another builder. It's here the builder Jammy Base. So with Ubuntu Jammy, they did not do like a smaller version for Java. So some folks actually like that, yeah, the builder Jammy Tiny is good enough for Java applications, and I usually also downgraded that. So if you want to have Ubuntu 20.04, I think, then you can also change that to Tiny instead of Base. It will work with your Spring Boot application. That means just like the run image above here is bigger, right? And if you think of the tiny one, so you have the smaller one. It's like 80 megabyte difference. So Paketo itself has like 3 different flavors. So you have like the base, you have the tiny, and you have, I think, the default one. So depending on like what kind of applications you're doing, your run images, your builders have more tools in there, and therefore like they matter of size, right? And usually if you have something like an executable, like a Go program, you would put that always like in a tiny one. But then if you do something like Ruby or PHP or whatever, you might need another one which has like all the things needed in the run image. So I think it's a great achievement that we have Builder Noble for the Java Tiny, and that they made like for Java explicitly like a tiny version which contains everything which is actually needed. Good. Yes, and you see also like the Belsoft builder down here. That's that one, and there should be the second one as well. I can't see it. The muscle. There must be another muscle one. Ah, it's below, I guess. Yes, it's this one here. You probably have seen this is like time machine, right? Because like the values were zeroed out because of caching reasons. It's showing like 45 years. And if you look at the timestamps, things are really changing quite often. I'm surprised, right? So that's super nice. So there is something going on in this Buildpack community. Great. So now we have learned that we could use a different builder, and we would get like a specific version of Java installed, and we can also change to Alpine or whatever kind of like distribution you want to use. There is even in Paketo the possibility to use builders for, let's check. I think, I don't have that installed here, but I can just change to my local machine. So pack suggest, we can actually let me see. Here we go. Yes. So you can actually see that even Paketo has Buildpacks for UB8 from Red Hat. So you're not even forced like for using Ubuntu or Alpine if you need to. Okay, let's jump back to my presentation. And yes, if you want to choose like another one, like the Chemi version, you just place it there. You can also use a digest at the end or colon latest if you want to. So you can really like switch between the different things. Of course, it should not be missed, right? Graal native images, finally, because we can compile things now down into an executable, which might be quite nice in different use cases. I have a customer where they like at morning at 9 o'clock, they need to scale up, like not like crazy, but like multiple instances, and then they will scale down their applications for later. And since the application actually is not changing, it's good, it's fine. So, so the problem actually with this native images is, and you see it here at the beginning, it's the build times. And we know it takes like way longer in the pipeline now if we create these artifacts and create executables out of them. So you could imagine that you basically move the computation power, which you are not using at startup, into the build pipeline. And now the question is actually, do you start your application enough often to compensate what you have spent for building the native image in the pipeline? If you just think of like resources, if you have no releases for 2 months and every day you need to spin up like 8 times a new instance and you go down again and maybe you have some peaks during the day, it's maybe perfect. But if you roll out your application daily or hourly and you always create the native image and you're not spinning up enough instances all the time, then it's not worth it. So like use cases, for example, like functions or serverless in general would be a great use case, right? Because there you spin up your instances quite a lot. So you have to think of that you need to compensate the amount of time you need for the startup in your build pipeline. And of course, during development, you also don't do like native images. So that means like certain issues can be only found when you deploy your application. That's just like the other challenge. I have here 2 versions I have benchmarked so that you can see like how they behave with default behavior. So I have benchmarked native images with the community edition. So that's like Liberica Nick you get from Bellsoft. That's like Red Hat Mandrel. That's also like just the community edition you would get like through the Buildpacks by default. And this one has no, I mean, it's not optimized like for all the things. So that's why I included additionally like the Oracle version. You can actually get from them for free and run it in production. And they have more optimizations. And I did not go like one step further because they have a thing called profile guided optimizations. So basically you would instrument your application, you would run a load test against it, and you would compile or create the image again. And because of this instrumentation, basically like they know how your application will behave in production, and they can do already the optimizations for the native image during the build time. So you have kind of like runtime performance when you use the Oracle Graal VM native images with profile guided optimizations. And that would be just like another 2 or 3 steps basically like to do, because you need to build it with the instrumentation, you need to do the load test, you build it again, and then you have the artifacts. So for the numbers I have here, I didn't do the profile guided optimizations, but you are seeing actually that the numbers look nicer with the Oracle version than just like the community edition or what you would get from Bellsoft, Liberica Nick, or Red Hat Mandrel, and so on. So if you need to consider this, it's definitely like a good idea, but choose the right one because you can actually gain way more. And we can also see the numbers. They look quite nice and they're way better with my current setting. I'm impressed. Because in the past it was often like this, that it was like flattened out at the end. So that means like it was never like the same or better than actually like the Java version, but now the numbers show differently. There is another thing I don't want to miss, which is also a very nice feature, which is called crack, and you probably heard of crack. Crack, which is coordinated restore at checkpoint, is basically a feature you get from certain vendors out there. Not all of them actually support that. It's because it's an additional feature. And I remember that people were saying on Reddit and the mailing list that crack will never make it into OpenJDK by default, because OpenJDK is meant for desktop and it needs to run on Windows, and crack does not run on Windows at all. So crack is basically like a feature similar to ground native images, just with the difference that we can restore a dumped process which was dumped to disk, and we just like restart that one. Good. So how does that look like? So you would actually build your application, and I think we can actually look that up in my examples, because it's way nicer to show things here in the code. So I have here also my crack examples here, and we can use, for example, crack 21, and you will realize I have built in a script here in my crack example. So I need to run it via script because there is no build pack which exists. So what I'm doing is I'm using Azul Zulu because they have a crack thingy. And of course I need to mention Azul and not always Bellsoft, right? So that's why I'm using here Azul. And I'm building my application. And I'm building my own Docker file. So my Docker file then creates me, or is creating the whole container for my thing. And I install Azul Zulu with the crack part in there. It's a separate build. It's like a build with Java effects in there. It's also like a separate build to download with crack. Then, additionally, I need to run it in a privileged mode. And that's already like very strange. And you see also some parameter regarding here, the U limit I need to pass. And yes. So I need to run the whole thing when I create a container in privileged mode. Then basically, when I run it, you will see I will do the dump. And then afterwards, I'm going to change the entry point for my container. And then I just can run it. So this is just a script which I need to go through to build the application. And we can just do it afterwards together. So my Docker file just consists of my Ubuntu 22.04. I have here my OpenJDK installed. It's not even with JLink and so on, just like simple. I add my fat jar to it, but you learned we should explode it. So I also just do it the simple way here. And I just like add my entry point script here. So let's do that together. And you can see how it looks like. And I'm switching back here to my machine, crack 21. So I'm going to call the checkpoint script. And it's downloading now Zulu. And it's building my application, of course, because we need the fat jar. And of course, now I think it will do the tests and will start test containers to do the database tests and so on. Yes, we saw it just like popping up here, Docker CLI, it's downloading some things. Since it's not downloading it through the Wi-Fi, that should be fast. So yes. So now actually the application is still testing. Yes, it connects to the database. Let's hope that works. We are waiting for MySQL. Yes, it worked. And now we are connecting to MySQL still, but differently. That's the reason why I did before always skip tests, right? So it was built. Now we're building the container. So we added the OpenJDK. You can see that, right? We just add the whole thing. And now we are waiting 10 seconds until the checkpoint is made. So the idea with the checkpoint is basically like we dump a process which is running, and it's now part in the container. So I think I have shown that the checkpoint script is the second. It's not here. It's actually here. I have a script in there with the entry point, so we see it a bit better. It's starting here the process. Then actually like we do something like J command, provide the jar file and say checkpoint. Now we dump it. And we are waiting until the dump is done. And that part is part of the container. And we are committing afterwards the container. So if I do check actually like which images are there, so you will see that I've created my builder, which is like the first one. And then afterwards, I have created the dump of my memory, of my process. And now I just like start the application and I need this checkpointed version. So I can do docker run checkpoint. And you will realize the PetClinic logo is missing, right? Because it restores the process from there, because it's already there. Now it needs to reinitialize Hibernate. And database connection needs to be re-established because you do the dump without the Hibernate and the database connection. So it has to be re-established. So you could actually say like we just invented a time machine for the whole thing, because this approach basically like takes a while until the clock is synchronized. So at the beginning you could, when you would print out like some dates, you would see like the date of the time when you built the container. And so we just like restored basically like the whole process with memory and everything. It's quite a nice approach. You have to be aware of like two things. One thing is that you need to do the checkpoint or the dump on the same CPU architecture like you would run in production, because otherwise it won't work. So that means like the same environment, same operating system, everything the same. So basically you would have to dump it in production. And the second thing is you might have secrets in the RAM when you start things up and do the dump, so that these things might leak as well, right? So you have to pay attention. There are ways around that, but that's a little bit more complicated. But just like to restore things should be super fast. Now, it took some while, I don't know why. I would expect that like milliseconds, but not 4 seconds. Maybe I can try again. It's quite slow. It's more or less like unexpected. It's probably also like regarding the database connection, that's why it takes so long. But besides that, if there wouldn't be that part, it's like milliseconds, like what you would see like with Graal native images. 10:01, yes, that's the time. Okay, cool. So that's like the crack part you have to be aware of. Crack support is already there since a while. So Spring Boot 3.2 and also Spring Framework 6.1. It's only available on Linux machines and ARM machines. And for Windows and Mac OS, there are simulators for that. So you can develop crack things. That's not a problem, but it's still slow because it's kind of simulated. So that makes no sense. So you need really like an environment, a Linux environment to do that proper dumps. OpenG9 has also features like that. So they call it like Creo support, which is basically the same, dumping the process and restoring the process. So I'm sad. There is no Buildpacks for that. I could create my own Buildpack, but as I said before, it's tough because we need the same CPU architecture. We need the same operating system where we run it afterwards. So you cannot do that like easily in a pipeline and then just like deploy it somewhere else. So you have some restrictions. Finally, we get to virtual threads. As we know, it was introduced in Java 21 quite a while. And now with Java 25, it even got better because like thread pinning should be not possible anymore. So therefore, you should actually like use virtual threads. And virtual threads is just like a thing under some circumstances, I will show you more about in a minute or so, really, really makes sense. So you just see that I added an environment variable here, and I say Spring threads virtual enabled equals true. Of course. We see also like startup times not really changed. Images and build times, it's the same image as before. It's just an environment variable more, right? So if you look at the numbers, you could say like, yes, we get like double, triple, 6 times, 7 times more through in the current setting. So, okay, that's astonishing. I did not expect that much. But what I want to show you actually like is the next slide, which actually like shows way more data. So I have made tables. I'm comparing different CPUs, which you see at the beginning, like 4 CPUs, 2 CPUs, 1 CPU, a half, and a quarter CPU. You have no virtual threads, and you have virtual threads enabled. And basically, what you see here is that typically you need enough CPU to have virtual threads because there is always like some overhead. So, you could say here, there are probably also like some false positives in the data, you know. But what you clearly can see is like with 1 CPU, you get like more than double of the whole thing. So you need at least like 1 CPU that virtual threads make sense. And that means also because like you have the carrier threads, you have the virtual threads on top, there is like some overhead, and also like if the startup changes and so on, I mean, it usually takes a bit more time for startup to do the infrastructure for virtual threads. You see that, right? And if you go higher, you can see quite a bigger improvements. So you need at least like one CPU. If you have less than 1 CPU, it does not make much sense, right? But make sure you measure yourself in your setting. I have done measurements also like with Java 24 and also with Java 25. But I find it quite surprising actually. And that's something now these days with modern Java, with Java 25 or so, you should definitely enable it because it makes so much sense. You get so much more throughput. You can have much more clients on the application at the same time. So that means like you really save resources while using virtual threads for a web application. Cool. Good. So, yeah. So what basically like reactive versus virtual threads and so on, right? So we know we have in Spring we have Webflux, which has the reactive stack underneath, and which usually like used to have like one core per reactor thread. And then on the other hand, you have like the virtual threads, which are just like the lightweight threads, and you can have many of them. I find it surprising that in the reactive implementations, also like virtual threads are used for certain jobs as well. Also like if you do like blocking things. So it kind of becomes a mixture of everything. So it still makes sense in certain cases, like, for example, I would say like gateways or so to use the reactive approach, but like for regular applications, I would not go down that rabbit hole and just like turn on the virtual threads in my application. Yeah, but there is definitely an impact on that. Good. So let's sum up the things, actually, like what we have seen. I know we have a bit more time, but I'm sure you are happy when you can leave like in 10 minutes for lunch already. So let's talk about like what we have seen. We have talked about like no optimizations with different Java versions. We learned always use the newest versions because they make a huge difference. Then we talked about some JVM tunings, or more like on the simple side. Of course, you can do more. But definitely what is really awesome is this Java memory calculator, which is just built in the Buildpacks. So you don't need to think of the sizing of your heap in your Docker containers because it's always calculated from scratch. We have been talking about setting different garbage collectors, setting different parameters regarding the smaller object references and stuff like that. Yeah. Then we talked about some few optimizations which you can do in Spring Boot, like lazy beans, just turning them on so you have faster startup, or for example, not adding actuators, also like removing dependencies was a part in this part, and also like the config location, fixing that one. Then disabling JMX, I showed you, you don't need to do it because it's already done, basically. And then we talked about AOT processing, which is generating basically all this dynamic discovery of Spring beans in your class path. And then we jumped into like JLink and app CDS and AOT caching, and also like other approaches here with different JVMs and even like the Graal VM native images. So there are a few conclusions to that. Your application might not need a full CPU at runtime, but they need enough CPU to start. So it turns out that like a best practice or like a good practice would be to have at least 2 but 4 cores just to start your application. Because the initialization, which is done at the beginning, takes resources. And if you could give your application like 4 CPU to start and you can scale down later, that would be awesome. So just like to get that peak load basically covered, and then afterwards your application is probably most often just idling. There is a nice blog post about that from Dave Sire, which is also mentioned down here, and just have a look at that. So it basically like covers the points as well. Then another thing is we have to be aware of that every application has different requirements. So I did load testing with the PetClinic, also like in a very specialized environment. And I know even like just benchmarking this and telling you afterwards like, this is so much better, there is not all the truth in there. So therefore, make sure that you benchmark your own application and you check against your setting, because I just can give you some ideas what you can do, right? And find your own optimal configuration. I think that's like very important. Yes. Then we also just learned that there are other runtimes out there which you could use, like Crack or Creo support to speed things up at startup. You can use Graal native images. You might even use other JVMs like OpenJ9, which are excellent for the memory consumption, memory usage they have. They're maybe not so great for other things, but if memory is your problem, then give it a try, right? And then on the other hand, we also learned that sometimes it makes sense to pay for some JVM distributions because you get some other exciting features. And just want to highlight like what we have seen with the Graal VM Oracle edition, or which is called like Graal VM3 from Oracle. It just has like optimized features in there you don't get in an OpenJDK. The same might apply to other vendors. So sometimes it makes sense to pay for a subscription because you need certain features, right? Okay, so there are other ideas I want still to elaborate on. I've been playing with Crack, yes, but still not with Buildpacks. I could build that my own, right? But there's still like some drawbacks, and probably it would not be good enough for you because like you would probably like create the image in the pipeline and then deploy somewhere else. So, and we learned we need to have the same architecture for the CPU and things like that, and also same operating system, the same version of Java and everything the same, right? So that's quite challenging. I was playing around also like with an obfuscator because I thought maybe we can do something like shrinking the class files so we can reduce the image size. It was quite a challenge because you can imagine when you do component scanning, you get so many classes called A, B, C, and D, and Spring does so many things with a name, with an implicit name. It's just a mess, and you start like excluding everything which is annotated with component, and it's just, yeah, in the end, you can just like disable everything. Your jar file might get even bigger. Yeah, so challenge is still there. You could do more JVM tuning as well. And also, like, of course, there will be some other features with Project Laden, which has the goal anyway to start up or speed up the startup in Java. So I'm really excited about that. And we saw today two things which are related to this, app CDS, but also like the AOT caching. These are just the starting point of that project, and it should become even faster in the future. Great. So think of the following. We have done quite a lot of optimizations. We talked about dependency cleanup, DB drivers, which were unnecessary, actuator, Tomcat, WebSocket, Jackson, for example, just like remove dependencies. Think of using different builders. Think of using JLink. Think of doing parameters, in this case with the JVM memory calculator, using app CDS, using AOT, using AOT caching, using lazy beans, using the fixed location, using virtual threads, and so on. So we could like put things like in different ways together. And the only thing what I want to show you here is like your thing might look way better if you are just like doing the right optimizations. Pick the ones you think work for your case, and then actually like you might get way better results. So as you can see here now, I have been using the Belsoft builder with Alpaquita and Muzzle, and we could like shrink the image size by 90 megabytes. The startup time is like almost 3 seconds faster. You see also like the RAM use is better. We have more throughput. We have better response times. So you can just like do a few things by applying those techniques I showed you. Also doing things, for example, like with a different builder. Now in this case, I used the tiny builder for Java, and also like the optimizations. And you can see like you can bring things down quite a bit. I even added the approach for the AOT caching on the bottom. So you see actually like you can really make a huge difference from your application. Great. So that was it from my side. I hope you enjoyed it. I hope you could take something with you. And I would hope that you could take like 1 or 2 things with you and change that on Monday in your application. And you will see like a difference, or at least like you get some inspiration. So my question to you would be like, did I miss something? Do you have seen like in the wild other ways how you can improve things? Please let me know. or just like, let's get in touch later. And I will be still here till tomorrow. And yeah, would be nice to have a chat about things. Great. So if you have missed the slides and if you have missed the examples, you have the last chance to take a picture. And that was it. Thank you very much.